someone operating like a construction startup, someone thinking like, oh, construction is so inefficient, I can make building more efficient. I can sort of mass produce buildings just like Ford did for the Model T. And lots of other people have like had this idea over the years and tried to execute on it. And they mostly have gone bankrupt trying.
Hello, data nerds. My guest today is Brian Potter. Brian is a structural engineer and author of Construction Physics, which is a weekly blog about economics, technology, and the productivity of building and infrastructure. He's also a senior fellow at the Institute of Progress, where he's exploring why construction productivity has stagnated while the rest of the economy has accelerated. Brian, welcome to World of DAS.
Thanks for having me.
Super excited. Now, I'm a huge fan of Construction Physics. I read it every week. I send it out to my, all my newsletter, my 5 links and everything like that. I really love it. But I've been meaning to ask you this one question, which is, okay, I live in Northern Virginia, often drive on the GW Parkway. Mm-hmm. For the last 3.5 years, there's been this 2-mile stretch, which has just been under construction forever. It didn't seem like they make any progress at all. I feel like if I was in China, this would have been done in like 2 or 3 weeks. Like, why does it take so long just to slightly move some structural things on a highway?
So my sense is for roadways specifically, I think there's a lot of what you would call like collective action or coordination problems, where it's basically there's a very large reluctance to like disrupt existing operations in people's lives. Basically, people don't want to like close down a main road to just rebuild it, even though that would be much faster. And so they have to like structure things in such a way so it's as minimally as disruptive as possible to sort of the existing users of the road. And
what they did is it was like 2 lanes each way. So they made it 1 lane each way, and it's been 1 lane each way for it'll probably be another 5 years before it's done.
You keep the lanes open. You try to maybe minimize the super disruptive stuff. So it's only on nights or only on weekends or only on, certain days or whatever. And then all that difficulty just ends up adding at quite a bit of time. I think that's a big chunk of it. And you see that in like various other guises as well. So for like New York subway construction, they famously will want to like excavate all their stations instead of just coming in down from the top, which is a construction method called cut and cover, which is often much faster than just having to tunnel in from below. You just cut open the road, build up your station, build the road back up. It's quicker to do things that way.
And then under New York, because you'd have to like close down Second Avenue.
You'd have to disrupt all the existing, disrupt every existing operations. People already like hate these like big disruptive construction projects, right? So you do this more expensive, less disruptive way. And there's, that sort of not, difficulty of getting the people affected by something to sort of go along with what you're trying to do is often quite difficult. And so in like, you see that show up in like other ways, like horizontal infrastructure construction generally, like you're trying to build a transmission line and you're trying to get sort of the right of way from all the existing landowners or whatever. That can be quite difficult. That's a major blow or something that slows down.
Would you get the right of way first before you started anything? Like,
you do, but like
that might take 3 years, and then
acquiring all that. It's just another example of like acquiring all that right of way takes like a very long time, or whatever. So that's one of the reasons why it takes like 10 years to build a transmission line or something in the U.S.
Right. And then in a place like China, they could just like force everyone to do it.
And in the U.S., the U.S. used to be more willing to just like do this disruptive shit basically, and like upend certain people's lives. So like build some big piece of infrastructure, use eminent domain and stuff like that. And people used to be perhaps more tolerant of it, or perhaps they just had less of a say in whether it went through or not. But for better or for worse, we are often will sort of bend over backwards to sort of not disrupt existing operations for things, much to the detriment of actually getting stuff built quickly and
There is some sort of
efficiently.
narrative that like regulation is a massive percentage of cost of construction. Like, where do you kind of fall on that?
So it's a complicated question. I think it's definitely true. I think it's definitely true that regulation has made stuff more difficult to do in construction. The question is to what extent that differentiates construction from other industries, because regulation of everything has gotten a lot more stringent over time, right? For manufacturing,
Yeah.
agriculture, blah blah blah, and those industries have seen like substantial productivity increases. And so the question is like, is construction more regulated than other industries? Is construction like differentially affected? Is regulation like uniquely burdensome to construction in some way that it isn't in other industries? And I think there's some evidence that is the case, that construction is, regulation is like more stringent, affects construction more than other industries. One way that shows up is that this is a little bit morbid. The death rate of construction workers, like on the job, has fallen a lot more than the death rate of like agriculture or manufacturing. So construction has gotten a lot safer over time than like other industries have. And part of that is because, and if you look at like OSHA fines, fines for like workplace safety violations, they're way, way, way higher in construction than like any other industry. By far, the most industry that gets fined is construction. And so there's these pieces of evidence that suggest that construction is a little bit more affected by regulation than maybe other industries are.
Okay, interesting. That's actually is there a, I mean, you at one more point you worked at Katera, right?
Mm-hmm.
And I love that idea of being able to like modularize things in some sort of way. Like, why did that not work?
So that's a pretty standard playbook for like trying to, someone operating like a construction startup or a new construction operation. Someone thinking like, oh, construction is so inefficient. It's, everything is built on site by hand. It's very, very labor intensive. Buildings, each building is kind of unique in most ways. I can make building more efficient by doing it in a factory. I can sort of mass produce buildings just like Ford did for the Model T, and I will use that to sort of make the whole industry more efficient. And lots of other people have like had this idea over the years and tried to execute on it, and they mostly have gone bankrupt trying to do it.
Why is that the case? Is it just because like moving it is really hard, and or like the final assembly on site is still so big, or
It's sort of a complex bundle of those things that you mentioned and other things, but at a high level of abstraction, it is very hard to sort of cut labor and efficiency, out of the process and kind of make it more efficient. It's hard to like, even if you move it into a factory, it's very hard to like dramatically rework your process in a way that you can make stuff really, without labor, without like adding cost back in somewhere else in the process. So you move your process, your construction process into the factory, you're producing, some sort of module that you're going to, make your building out of. But you still, even if it's done in the factory, there's still not all that many tasks that can be like really, really automated the way that like, a car assembly line is very, very highly automated.
And why? Like, I feel like bathrooms are bathrooms, or walls are walls, or why is this like this?
Yeah, so it's sort of a complex bundle of things. But one reason is that buildings are like buildings are like different enough, and you can't transport your buildings far away, that like the amount of volume that a single factory can produce in terms of like number of buildings is like not all that high. You can produce like even a pretty
even the insides of buildings are so different, like the countertops and stuff.
well,
It's like
a lot of that stuff is factory produced. Like windows are like factory produced these days, stuff like that. So you do see like a creeping level of like modularization, but it's like pretty like small components. The stuff that like can be like is like repetitively used in very, very large numbers and doesn't change much from building to building. That stuff does tend to be like factory produced. So
doors,
drywall
windows,
sheets,
those types of
doors,
things. Yeah.
fans, stuff like that.
I assume like even the wood like is like pre-cut to the right, the right 2x4s or something like that, or
it is not to as much as you would think. Typically on site, they will get like a big bundle of lumber and then just like cut it to what they need on site. Basically, because the workers can like do that like reasonably quickly and like
you might need like a tiny fraction of an inch difference or something or whatever.
Yeah, and like and another sort of big thing. This kind of touches on another big thing as to why it's so difficult to sort of factoryize to some of construction, is that the amount of equipment and machinery that you need to like duplicate what like two guys can do with like a hammer and a saw basically is a lot. You need like all this material and these components are like big and bulky, and they need a lot of like pretty substantial equipment to like manipulate them. And so it takes like hundreds of thousands of dollars worth of equipment to like even do like relatively simple jobs that like two guys could do like really, really quickly.
And is it because things like homes are still so different? Like every time, like whenever I go to someone's home, they may have like one of four cars in it. So the cars are all the same. They all have the same phone in the home. They all have roughly the same TV. But then like each home is like complete snowflake. Like if the homes were more similar, if there's only like 7 models or something, would it be a lot easier?
To some extent, homes are different. A lot of that is dictated by like, site constraints. So like,
you're on a hill.
Different. There's a hill where there's trees, there's water, stuff like that, or just the size of the plot is like different. Where the utilities come in is different. So there's only so much that like you can make it uniform just by the very nature of like you're building this thing in like a specific place with like specific requirements. That's part of it. And then kind of to go back to what I was talking about earlier, there's only like so far that you can like ship this stuff because it's so big and so bulky. And so a car factory will produce hundreds of thousands of cars a year, millions of cars a year. But it's pretty hard to get more than like a couple thousand home units out of like a single housing factory. Even stuff that is like really, really repetitive, like a manufactured home, like a mobile home. Those factories tend to be like pretty small scale. They're not like all built in one factory in Nevada or something. These big manufacturers, they have like 20 facilities scattered across the country, each one making a relatively small number of these homes because there's only so far that you can like ship this stuff economically because it's so big and so bulky. So these things have like a catchment area of like a few hundred miles, and that's your market. So you have a few hundred miles that you can ship it. Within that, you have a bunch of different, demands for different kinds of housing, different customers that can afford different things, different plots, stuff like that. And so like the uniformity really gets like whittled down.
So if we want to drive down the cost of construction, what are the big drivers that we could do as a society to do that?
I'm pretty optimistic medium term about automation and robotics, just because if
on-site automation,
on-site or like some combination of like really something like a pop-up factory or something like that that you set it up near the site, and then your shipping distances get greatly reduced. There's a lot of popularity for that idea too, but just at a high, and the reason is this basically is sort of uncreative, is because I can't think of any like amazing ideas of what would optimize construction. Right, I spend a lot of time racking my brain over it. Lots of other people have lost large amounts of money trying to come up with like a really clever idea. Nothing really seems to work. But if nothing, even if nothing else works, if you replace your relatively expensive labor with a robot that costs like $5,000 or something that can work 24 hours a day, that would effectively solve your problem.
World of DaaS isn't just a podcast. World of DaaS membership is a private, invite-only community for founders and executives of important data and AI businesses. It's a place for off-the-record, high-trust conversations focused on the biggest questions data leaders are facing. The community is about peer learning, curated intros, and access to private events. Everyone in the group is building or leading something meaningful in data. If that sounds like you, apply to join at worldofdaas.com. That's worldofdaas.com. Now you have people using forklifts and you have all these different tools that these people are using, which do make them, I assume, much more productive than they were before.
You would think that and that's, I think, one of the big sort of mysteries around the construction industry is that why that didn't have a bigger effect, like the mass introduction of like power tools. Basically, we don't
the
see
number of people that you need to make a house and the number of man hours seems the same as it was.
It is.
Many years
very,
ago.
Very similar. And so, the mass introduction,
which is crazy,
of power
right?
tools,
That doesn't make any sense to me.
Yeah, that's very strange. And what's also very strange related to that is like between, say, 1950 and like today, the technology of like putting up a house hasn't changed that much. There's some stuff that's like different. Drywall was pretty uncommon in 1950. It's ubiquitous today. Stuff like wood trusses became adopted. Certain materials became more common. But the basic process wasn't all that different. The basic materials you were working with didn't change too terribly much. But between, say, like 1900 or like 1890 and 1950, it changed like completely. Everything changed about it. But even over that earlier period between like 1890 and 1950, the data we have suggests that it didn't really get that much more efficient building. We don't have great data, but we have like, some like, cost at time series and stuff like that. And it doesn't seem like it really got that much cheaper over that period, even while the technology of building totally changed. So that's, again, there's still a lot of like reasons that this is like not amazingly well understood as to what specifically makes it so difficult.
What countries are doing this well? Are there countries that we could like look to at all?
So I think there's a kind of a couple ways of thinking about it. There's not, from what I've seen, there's not really any countries. I've only seen a limited number of data sets, so some other country out there might surprise me. But there's not that many countries that are like avoiding the problem of like construction costs constantly going up, construction productivity relatively flat. As far as I can tell, they also, if you look at like the, cost per square foot or whatever, or productivity indexes, they kind of show the same trends as the US or whatever.
And some of the countries, like their labor costs are going up much faster than US. So I presume their costs are going up like with labor or something, right?
Yeah. Or just they're under like similar sorts of constraints. What you do see is that other countries operate like a lot. Often they will operate closer to the efficient frontier, like the most inexpensively you can like sort of put up a house. So like an apartment building in like a major European city or something will be much cheaper to build than like a major US city, like a coastal city.
Why is that?
Again, it's like a combination of things: high labor costs. A lot of these coastal US cities have very like strict and burdensome regulation. Like New York has like very high construction costs, and they have a lot of like really, really onerous regulations for building. Like it's very hard to use like a tower crane in New York for some reason. So you have to use these like smaller, less efficient cranes that take longer to do. You have to use like union labor for a lot of stuff, and that drives up costs. And it's kind of things like that.
Is it also like you have to guard against like the wind that may only happen once every 400 years or that type of thing? Or
that's less of a thing. There's some of that. Like US in general has like, I'm not sure about wind, possibly about wind, but like high seismic stuff. There's some places like earthquakes. You have the earthquake design is more stringent in a lot of places in the US, especially on the West Coast, than it is in most places in Europe. That's not like I would not say that's like an enormous driver of cost. It's a factor, but I would say it's much more, these sort of like, regulatory labor costs, general like coordination issues, stuff that's like very highly regulated. European countries tend to be like,
I mean, every time you read anything on this, you always say something like France can make their subways at 1/10 of a cost as New York, or you always see these like weird stats like that, and it just seems like you're like, well, France, really? Like, why is
France.
France like,
Spain, very, very good at building subways very, very cheaply, which again, you don't think of Spain as like, the incredibly
right?
efficient country of Spain, right? That's not like the first thing that jumped. Italy, too, another one. I think they're pretty good at building subways. And that's just, again, there's like this like sort of complex bundle of issues. The sort of government agencies in charge of like managing these metro construction projects, they a lot of time don't have like the in-house capacity to like do the design and manage them very well, and so they end up outsourcing a lot of that, and so you end up with these like sort of principal agent problems where like they're not necessarily doing a good design, and the agencies aren't be able to oversee them very well, and there's sort of conflicts at work, and you see stuff like that kind of across the board.
And is the hard part
Sort
about
of
building subways literally boring the tunnel that they go, or is it just like, or is it all the other stuff afterwards, like the tracks and the trains and the getting people there and all that other types of things?
I'm not an expert at transit construction. There's so many people who are like so enthusiastic about like transit construction that I've in some ways like stayed away from that topic. But my sense is that a lot of these are like use like pretty similar technology to actually like drill them. Use like a big tunnel boring machine. Basically, it's more like the doing it with like an efficient amount of labor. I think that and doing the coordinations, they're doing the right jobs in the right place at the right time, and stuff like that is I get the sense of what the some of the issues are.
Okay, interesting. What you also study? You spend a lot of time studying shipbuilding. Why is that so important?
Well, it's important now because if you think their major like global competitor is China, and you think there's a reasonable chance we're gonna fight a war with China in the South China Sea over Taiwan or something like that, then that's going to be like a naval conflict, right? You're going to be able to build a large number of ships, and then just more generally,
why would ships be important in like a drone world?
Well, because you need to, you need your, ships close to sort of like deploy the drones, deploy larger aircraft, fire missiles and stuff like that. It's not like these drones can all just come from, you have to get your stuff into the sort of field of combat and stuff like that.
But for China, I'm saying like they're already there. They don't need to have ships in their ships.
They're building they're building
like the U.S. would need some ships, right?
China is building like enormous numbers of ships. China has a bigger navy than the U.S. now.
Yeah, but I guess why would that be important in a conflict? In like in the Ukraine conflict today, like naval ships Russia has a massive navy and Ukraine doesn't, but it doesn't help them because like their navy can't get anywhere close to Ukraine because of the drones.
That's a good question. There's a lot of thoughts. I'm not an expert on this. If you want an expert, you should talk to my friend Austin Vernon about like drone combat as it relates to sort of modern warfare. But I think in general, it is not clear how drones are going to interact with sort of modern ships, and you're still basically going to need modern ships to transport weapons, to transport troops, to transport larger aircraft and stuff like that.
Or there'll be like counter drone things, or
countering drones, stuff or whatever. Like that. Drone carriers, I think, is a possible area where you might see, ships and stuff like that. But anyway, you're going to need a lot of ships for a conflict in the South China Sea, or basically anywhere, because the U.S. is basically protected by oceans from most countries that could be a potentially major adversary. And so for any major conflict, you basically need ships to move your sort of material around. So in like, the Gulf War, basically, for instance, we needed a huge number of ships to move the material over to the Middle East.
And I assume most of those ships today are Chinese-made ships that you're.
Yeah, a lot of that. There's actually, I think, a big issue with whether we have enough, like, sea lift capacity is what it's called, to sort of move large amounts of military material to sort of a foreign country if we needed to. There's a lot of that capacity, I think, has been reduced quite a bit.
And initially, like in the 50s, like Japan was dominating, and then maybe starting in the 90s, like China started dominating. Like how do these shifts kind of, was it like a from a top-down country perspective, where they say, okay, this is a priority and we're going to make this happen? Or how did these shifts happen?
It's pretty much that. It started like as a top-down priority. It's like, we're going to be we need to have a strong shipbuilding industry for, whatever reason, because we're a maritime country and we get all our goods via ocean trade, because it's a key component is to building up your sort of industrial economy more generally, because it sort of builds manufacturing capability. It's a big user of steel, which we're also trying to build up and stuff like that. It's a way that it's something that we can sell to foreign countries and earn foreign exchange. So anyway, basically it was like a sort of a top-down thing as the way these countries decided that was important, and they just invested huge amounts of money building up the infrastructure to do it. They all had relatively low cost labor. They ended up getting often low cost steel too. Didn't necessarily start out with low cost steel, but they built up their steel industries over time and were able to reduce their steel prices. So they were able to reduce the cost of their inputs so much that that they were able to build these ships very, very, very competitively.
So I don't. How does it actually work? So these ships are massive.
Mm-hmm.
Are you is there some point where you're literally building it on the water, or or is it because I don't even know, you can't put them in a building that would fit or are you building in this modular way and then you stitch them together on the water? I assume at some point the final assembly of the ship is on the water, right?
So it's usually done in what's called a dry dock, which is basically a big recess with the concrete bowl, basically, with the flat on the bottom, and they basically build the ship in big chunks, big modules, and they will it'll be one small chunk.
But it's
of
built
it all,
it's
all
outdoor, right? I assume it has to be outdoor. It's not a roof over it, or
most
is
of
your
them
roof?
are outdoor, but sometimes they will build these things indoor. There's a few facilities that have it's just a big giant huge building with a dry dock in it they can flood. I think some cruise ships are built that way.
Okay.
But yeah, there's some facilities that are indoor, but most of them are just a big outdoor dock. And so they assemble the whole ship. It's sitting on this the bottom of this dry dock basically. And when the ship is done, they open the gates and they flood it. The ship floats and then they sail it off.
Oh, that's so cool. I imagine just the infrastructure of that is massive. It's part of the reason the US just can't do it, is just it's just takes a massive amount of it imagine it's just really hard just to build that kind of infrastructure.
It's not so much that it's physically difficult or so complex to do. That's one of these reasons that you keep seeing new countries come along and get a big share of the shipbuilding industry, is because it's relatively simple to do compared to something more complex, like semiconductors or aircraft or something like that. It's much simpler to build a ship than things like that. But it does take a lot of space, and a lot of these existing shipyards in the US, they don't have space to expand. And so all these countries that built up their shipbuilding industries over time, they were able to build this big, huge new shipbuilding facilities and willing to invest the money to do that in these spaces where there was huge amounts of room to expand, and they could, build all the room to move parts and pieces around and store the big modules and stuff like that. In the US, shipyards, they don't really have room to expand in the same way. There's not necessarily the money has not been allocated to find, places to build big, new, huge, giant shipyards. Perhaps someday there will be.
I went once to the Boeing aircraft facility in Seattle.
Yeah, the Everett factory.
Yeah, it was amazing. First of all, it's so big. It's just just the scale of it was so cool just to see. But why are Airbus and Boeing, why do they persist as this duopoly, where it just seems kind of it's the last place, and whereas the U.S. has lost things like shipbuilding and so many other types of things.
Yeah, I mean, there's my sense is that the aircraft industry is so small in terms of number of airplanes sold a year. For a large commercial aircraft, Boeing 737 or whatever, they only sell maybe 1,000, 1,500 of those a year. And if there's not that just much room to carve up the market between all that many participants. And so you saw,
I assume safety is really important there.
Yeah, it's just so expensive
and stuff.
it's so expensive to build and develop a new model of aircraft, partly because of safety, partly because you have to test it so much. It's so expensive. You need to earn that back over like a certain number of sales. And if the market is carved up too much, there's not enough basically market share to go around. And so what you saw in like the 70s and the 80s and 90s or whatever is that you had more competitors, and then they just got like slowly whittled down because it was just so expensive to like build these aircraft.
Right, the McDonnell Douglases of the world.
Yeah. So like Lockheed was a competitor in like commercial aircraft for a while, and they developed this aircraft called the TriStar, and they lost it cost them like billions of dollars to develop, and they only sold like a tiny number, and they lost.
I never even knew Lockheed
they lost
made
like
commercial.
Huge amounts of money on it. And
I don't think I've ever flew on a Lockheed commercial aircraft.
Yeah, it would be pretty uncommon because it was built in like the the 70s or whatever. Okay. So it would be pretty uncommon. I think there's maybe like one still flying. It's like used for like, I feel like it's used for like some special purpose or something like that. But
are there examples of like recent infrastructure projects in the U.S. that are going really well? Like, I don't know, maybe in like some place in Texas, and something we can learn from them?
So the U.S. is pretty good at building like a lot of like natural gas power plants, stuff like that. Those, if you look at like the time lapse of like those going up, those get built like really, really quickly. But they avoid a lot of these like problems that we were talking about earlier with so many infrastructure projects. Like it's not like a transmission line or a subway where you're like incredibly disruptive to like a huge number of people that you're trying to
like in the middle of nowhere,
getting the permits or whatever. You're having to like get a bunch of like land easements or whatever. It's much so it's a little bit they dodge a lot of those like permitting difficulties and stuff like that. But like industrial facilities in general, like big we're pretty okay at building. Like a big car factory or something will go up like reasonably quickly. So stuff that avoids a lot of these like coordination challenges.
So basically, if you can build it out of population center, whether it's a power plant or a factory or a warehouse, like we can do it's when
you don't need like a approval centers. Of like a bunch of little individual landowners. If you don't need like federal government approval or whatever, if you can avoid like a lot of like your complex permitting problems, it's quite a bit more straightforward. We're a little bit better at it.
It's interesting because 20 years ago, there was all this talk in the U.S. about peak oil, not just U.S., but worldwide. And, right as the fracking movement was happening, but it's kind of like happening under everyone's noses. Mm-hmm. Do you have a sense of like why that was so successful? In some ways, it is like a manufacturing success for the U.S. Like why was that like so uniquely successful and so uniquely American?
Yeah, so it was this company in Texas, Mitchell Energy, I think of it, and they just experimented with. They had a sense that there was like you could extract large amounts of. I think it was originally used for. Anyway, they could extract large amounts of gas in these formations that like had traditionally been thought that you couldn't get it out of, and they just like kept fiddling around with their like drilling and sort of fracturing parameters for long enough, and kept experimenting with it until they basically cracked it, essentially, until they figured out, okay, here's what you need to do to sort of drill these formations in a way that we can extract large amounts of gas and energy from it. And once they sort of started figuring it out, more people sort of poured into the sector. They sort of more development. They kind of kept figuring out better and better ways to do it. And just in general, the oil and gas industry in the U.S. has been like pretty innovative. It's like very, very competitive.
It's very entrepreneurial.
Lots of like constant technology changes to sort of find ways to sort of do this drilling more efficiently and extract more oil and gas from these formations. So even for the past 150 years or whatever, there's just been constant innovation, pushing the technology forward. to try to make it better over time. And the fracking is, was incredible.
Well, why is that?
Huge
Why has
amounts
that
of
been
energy,
so uniquely American? Like, why? Like, it seems like in most other countries, they've got, if we can build something quick, they can do it. They can sometimes even do it way better than us. This is like an very industrial thing where it seems like America does it the best.
This is a good question. I have a vague sense, so I'm going to put something that's a placeholder that you or a reader or a listener can go look into lately. I think the way that the U.S. treats mineral rights is a little bit different than other places. I have a sense that in a lot of places, the government basically owns mineral rights.
Yeah, most countries, the government owns like whatever is below the ground.
And in the U.S., I don't think that's true. I think in the U.S.,
if you own an acre, you own what's
and then you
underneath
can
the
also
acre.
sell it basically. Yep. And I think that has been a key factor as to why there's like so much more incentive to like find ways to like develop, ways of getting minerals out of the ground, basically, oil and gas, than maybe in other places. I think that's part of it. But that's you'd have to ask somebody with a deeper knowledge of the oil and gas industry to get a more detailed answer.
And one of the things I loved was you wrote this like great essay on Bell Labs, which basically invented like so much stuff. It was such an innovative place. Like, why do you think they were so uniquely innovative?
Yeah, so it's this like sort of like perfect Goldilocks combination of arrangement of like parts and pieces, basically. So we had this huge monopoly that could funnel like huge amounts of money into this operation. And so they didn't really have to worry about competition, but also the monopoly was like so big that they were always on the verge of like being too big for the federal government to accept. And they were always worried.
You have to like waste money.
They're always worried that the government was going to like come in and break them up. And just so kind of like appease them, they're like, okay, you need to be like constantly improving your services and constantly driving down costs. So they had like a very, very long time horizon because they were like a monopoly. They didn't really have to worry about competition, but they were also very, very strongly incentivized to constantly be improving their technology and developing new capabilities that they could, hold up to the U.S. government says, look, we made this other thing. Please don't break us up. And then they just hired like extremely, extremely, extremely talented people and kind of managed them in a sort of very good way where they gave them a lot of freedom to sort of pursue whatever they thought would be useful. But they also sort of subtly directed them into sort of solving problems that were like related to the business that they were in, which is,
because like a Claude Shannon could have gone into like a university or something, but somehow they like were more effective in a Bell Labs, right?
Yeah. So like, Bell Labs, they had like huge amounts of funding, like the equipment was like much better. They didn't have to like worry about like teaching or like finding grants or stuff like that. So it was a very cushy job to like do research at Bell Labs. And of course, for most of, 20th century, it was also very, very prestigious. It was like more prestigious than like a major professorship at like a major university or something like that, which is not generally true at like industrial research type places.
And there's some people make analogy to like what Google does for research or what some other companies do for research. Google, they published a Transformer paper, which really has kind of like led to the AI revolution, things like, is there some analogy to today, or is it just like that was a unique moment in time, which will never be kind of replicated?
Google is probably the closest, there's a lot of, there's stuff like the Transformer, a lot of their AI work. They were funding like self-driving cars for like years and years and years and years and years, which is only now starting to like kind of, bear fruit.
Yeah,
or whatever.
Only a company with like a massive time horizon.
Yeah, lots of other stuff that escapes me at the moment. But even then, they're like a little more focused on like the bottom line. I think they tend to like spin their efforts out as like separate companies. A lot sooner than maybe would be turned into a commercial operation at something like Bell Labs. So I think even Google is perhaps the closest, but even Google is maybe not quite at the same level of like, truly free from like, immediate concerns about like competition. We only need to worry about making this sort of useful technology in the long run.
It seems like if you think of like you think of Bell Labs like the 40s and 50s, and then at some point you think of like Xerox PARC or in the 70s or something. Like, did somehow the innovations start to like move to like that type of place, or
So I would say that, yeah, Bell, after the transistor, which was like a huge deal after Bell
Yep.
Labs sort of invented the transistor, Bell Labs was like incredibly prestigious, and everybody was like, well, and then holy shit, if we can, if these industrial labs can produce like these hugely important, valuable like products, and so there was a lot of companies that were like, oh, I need to get an operation like that, like that in my own big company. And so companies like Ford, companies like Xerox, IBM to some extent, Exxon, they all set up these industrial research labs that were basically modeled on the Bell Labs idea, which was, hire a bunch of like super smart researchers, give them a bunch of like freedom to like do whatever they think is valuable. And they did a lot of like groundbreaking research or whatever. The IBM research has won a couple Nobel Prizes. Xerox PARC, of course, invented,
Yep.
a whole bunch of like modern computing technology. Exxon, a lot of the initial research for like the lithium ion battery was done there. But none of these like companies like really managed to like turn their research into like huge money making products or whatever. It was like they did a lot of like prestigious research and stuff that ended up being important in general, but not like especially valuable to like the company itself. Like Xerox very famously, never managed to really capitalize on its like PARC developments. I don't think Exxon really ever did anything with its lithium ion battery developments, stuff like that. So they just kind of had a hard time turning this research into sort of like products that like showed up on the bottom line. And so they all kind of ended up moving away from this model where they would like just give these researchers free rein to sort of do whatever they wanted.
There's been a lot of talk about like rare earth minerals in the US and how do we develop them more? How do we get more, whether it's lithium or copper, whatever it might be that's out there? Like, is that something you think that the US is going to have to do more to just be more self-reliant? And if so, like, how are we going to get there?
That's a good question. This is something is on my list of things to research. Rare earths. I have a big list of topics, and like you should learn more about rare earth mining. You keep hearing about it in New York Times or whatever. I don't know a huge amount about it. I get the sense that like the U.S. has a very large number of like deposits of these things. It's just a question of like, is it possible to sort of extract them in an economically
because it kind of rhymes with fracking in a way, right?
A little bit. I get the sense that the U.S. has not been like especially dominant in mining type developments. I think my vague sense is that that was like an early sort of casualty of like not wanting like these incredibly environmentally destructive and disruptive industries. And so it's gotten very hard to like open a new mine in the U.S. or whatever. Another consequence.
And also the process the rare earths is very
a lot of it's like pretty dirty, pretty gnarly.
Yep.
I don't know if like there's definitely more interest in like more self-sufficiency and stuff like this, for defensive purposes or for whatever reason. So I suspect we'll like get back, do a little bit more of it. I don't really know the trajectory. I don't have a good sense of what the trajectory of it will be. I don't know. I haven't researched this area all that much. So I don't have too terribly much to say about it.
So I was an engineer. I went to college in the 90s. And if you went to college when I went to college, and you were an engineer and you studied electrical engineering, computer science, maybe chemical engineering, this would be like a very lucrative field. If you studied things that are a little bit more traditional, aerospace engineering, nuclear engineering, mechanical engineering, et cetera, you probably didn't do like nearly as well on a relative basis over the last 30 years. And my guess is that a lot of people decided not to go into those fields because of that. Like, how is that affecting today's market?
Yeah, that's a good question. I saw something just the other day. I think if you look at like the top, median earnings by career or something, it's still all like engineering careers that are like right at the top of the list. Like electrical, but even, aerospace, all that stuff is like industrial engineering. All that stuff is pretty high up. I don't have a sense of like why, we're not, why we're producing fewer engineers than maybe we'd like, other than, it's become, I think for a lot of period in the 20th century, it was very prestigious to be like an engineer. Like that was something that you'd like as people aspired to be. I think the prestige attached to it is not nearly the same as it was.
And what do you think the reason is? I have a theory, but I'd love to.
That is a good question. I wonder if it's downstream of like perceived less technological progress in general, outside of a few things like semiconductors and stuff like that. So in like first half of the 20th century or whatever, there's all these incredible technology developments, cars and airplanes and, nuclear bombs and stuff. It's all getting like better and more capable and stuff all the time. And so an engineer is like that sort of technology personified, progress personified to some extent. And so if you're, an engineer who like sort of works on that stuff and you're sort of in some, vague or indirect way responsible for this like technological progress, that's like quite prestigious or whatever. But if the last 50 years have been like, a lot of this technology seems like it's maybe not advancing quite as fast. Things in many ways seem very similar than they did in the 70s and 80s and stuff like that. Maybe it's not quite so prestigious to become an engineer as maybe it was when you have progress looks a lot different. And maybe that's why China is able to produce so many engineers, or at least part of it is because they've really seen like huge amounts of like development, progress overall, and just like development, like living standards and the results of like building like huge amounts of infrastructure and how that's been able to improve people's
Yeah, that sounds right.
lives.
I mean, it seems like if you're an engineer, you want to actually build something. That is the reason you're an engineer.
Yeah.
You want to actually do something. So if like you could like build the SR-71 in like 2 years or whatever it took back then, like you're like, oh great, like this is amazing. Like that must be a really fun project to work on. If you work on that same project today and it takes like 20 years, well, like that's like your whole career to do like one thing. And so you might as well just like that same person just like goes into finance and makes money now, whereas before they could actually build cool stuff.
I've heard stories at like traditional automakers like Ford or GM or whatever, that you would have people who's like engineers who like they only work on like door handles or whatever. Like that's all that they do is like design door handles.
Terrible. Like imagine like 30 years in, it's like you could like show like the 3 door handles like you made or something. Like I don't know, it just doesn't seem like that exciting.
Anyway, what's your theory of why we're?
I think that's exactly it. Like, I think it's just that like you want to see what you did like in the wild, and you want like my wife's grandfather was a food engineer. He worked for General Mills. And he got to make like super cool stuff like Tang and Cool Whip and all these other types of stuff. Like every year he got to like come up with something cool. So it was like, he didn't make a lot of money. He worked for General Mills. He was just an engineer. But like every lesson every year he got to see like a new invention that his lab did come into, and then he could see like the neighbors buying that invention. So that was cool.
Cool.
Now, what is there is but it is, we do have a shortage of engineers in the U.S., right?
I don't know. I mean, it's I don't know.
You don't know. Okay.
I don't. Yeah, I don't know. I know we have, I know there's shortage, there's constantly concerns about like labor supply. I'm more familiar with the construction industry. There's constantly concerns about having enough like, construction workers and stuff like that. Like the average age.
Why aren't more people going into construction? Because it does seem like a fairly lucrative, like if you're an electrician or something like that, it seems like a very, very hard skill to learn. But once you do learn it, and once you're like, relatively competent, you have an extremely good guaranteed income, and it seems like so few people are going into these types of fields in the U.S.
Yeah, it's a good question. I think it's part of it is like kind of what we talked about earlier is like, the status of these things has been lowered relative to other things. There's so much emphasis on like going to college and getting a degree and doing some sort of knowledge work, basically, and the relative status of construction work has fallen. I think it's not quite as lucrative as like a lot of people say. You see these threads on Reddit. It's like, oh, you should go and be a plumber and then earn $150,000 a year. Very few plumbers make that much money. It's often quite
like maybe if you live in Manhattan and you have
yeah.
to spend like $5,000 a month on your one bedroom.
I don't think it's the modal outcome. I think a lot of these jobs are really quite taxing. Like to work in construction is like very physically demanding. Not necessarily have to be like super strong or whatever, but you're on your feet all day. You're bending back and forth in awkward positions. It's very taxing on the body to kind of work a lot of these jobs. So it's not like amazingly surprising that people are like less interested in that and more relatively interested in jobs where they can work in a nice air conditioned office and move numbers around in an Excel spreadsheet or whatever.
Yeah, that's a good point.
Yeah, like I've spent time doing construction work quite badly, I will say, when I did do it. And it sucks, man. And
pouring concrete.
And part of that is a personality thing where I'm not particularly well suited to it. But yeah, it was quite taxing. You're out in the sun all day doing manual labor. An office job is comparatively much more attractive.
Yeah, it is funny. Like these people, they'll do the office job, but then they'll go like every morning to Barry's boot camp or something.
Yeah.
What are some topics that you're researching beside the rare earth minerals that you haven't yet felt confident writing about yet?
So there's usually a pretty quick turnaround between like when I'm interested in a topic and when I start researching it and when I write about it. So there's usually not like I have a list of things that I like, want to sort of learn more about. But usually once I start learning about it and diving into the research, the essay starts to shoot up pretty quick. Water infrastructure is something I think I'm going to start devoting more time to.
That's interesting.
I just don't I'm a civil engineer, so you sit by degree. So you would think I would understand it very, better.
So you're talking about things like treatment plants, the movement of water, all that stuff.
How water infrastructure, works at a high level and, how it gets built, what sort of gets built and what do we need to do different types of water tasks and how much water does the U.S. use and where does it go and stuff like that. I just don't have a good sense of any of that.
Really. I 100% want to read that when you're right. That's super interesting.
That's a pretty important part of infrastructure that I haven't really touched on at all. So I think.
By the way, that does seem like, I don't know that much about it, but like intuitively, it seems like something like U.S. does pretty well. Like pretty much anywhere I go in the U.S., I can drink out of the tap, where that's not true in a lot of countries. The tap water, or it's like, I love the tap water in the U.S. Unfiltered tap water. It just tastes good. It's good, relatively good for you, I think. It's clean. It's ubiquitous pretty much anywhere you go. Like that is a weird thing that the U.S. does well.
Yeah, this is the thing I don't know is like how good is the water in the U.S. compared to other countries. That's actually a pretty interesting angle that I hadn't considered until just now. But like, how good is our water actually? You see stories like Flint or whatever, where there's
there are some terrible stories too.
in the pipes. But yeah, that would be actually interesting to compare. How good is the water in the U.S. compared to other countries? How does it vary across the geography of the U.S.? That'd actually be interesting to look at. So I'm going to add that to the list of topics to write about.
Interesting. All right. We have two more questions we ask all of our guests. One is, what is a conspiracy theory that you believe?
Oh, gosh. Yeah, that is a good question. I don't know. For a while, it really seemed like a lot of this UFO stuff. It was like, oh, there really are actually UFOs. And, everybody in the Pentagon just knows this and we just didn't really talk about it. So that was like becoming quite compelling to me for quite a bit of time. And then it was like, wait, are there actually UFOs going on here? Why isn't anybody talking about this? And then just recently I saw some article that was like, oh, this was just something, disinformation deliberately introduced by the Pentagon to like,
it's like a psyop.
Confuse some other people in the Pentagon, basically. So now I don't know what to believe. It still seems perhaps somewhat plausible to me. And I would love it if it were true.
Is there any conspiracy theory in like the construction industry that people have? Like there's some monopoly that's trying to move prices or anything? Or
That's a good question. I've been seeing discussion as to like there's like a conspiracy among home builders, like large home builders, to like restrict the availability of land, to basically effectively drive up prices, essentially.
oh,
And
interesting.
I haven't spent a ton of time looking into it, but you are historically in the US, home building was like really, really, really fragmented. And even the largest home builders only had like a pretty small chunk of the market. That's not nearly as true today. And the largest home builders have like a pretty big chunk of the market, actually.
And
So
probably even locally, they have a bigger chunk.
yeah, so like,
There probably is like where I live in Northern Virginia, there may only be a few or something.
yeah, companies like Toll Brothers and stuff like that, Lennar, like these big national companies are a lot bigger than they used to be. So haven't looked into it deeply, but it doesn't strike me as crazy just based on what I know about like the changes in market share over time.
There's also been some conspiracy theories that like the train companies have been against the trucks, or or against the pipes, or it's like these other like different conspiracies that are like
Oh
they're out
yeah.
there.
I think a lot of that is just like, the economics of something is bad, and so it doesn't work out, and people
Yeah.
don't accept that operation or the conclusion or whatever.
Our last question we ask all of our guests: what conventional wisdom or advice do you think is generally bad advice?
So my thinking about advice is that all advice is kind of like directional. So it's like it takes you in a direction from a certain point, but you should do more of this. You should do less of this. You
Yeah.
should, spend more time exercising. You spend more time with your family. You should spend less time working, blah, blah, blah. But because it's directional, how good it is depends on like where you are starting from.
Yep.
There's people that are like, you work too much and spend less time with your family. You should spend less time working, more time with your family. There's people that do not work nearly enough and would be well served by like, buckling down and focusing more on your job and grinding it out or whatever. So I think in general, people place too much emphasis on like broad advice that's not tailored to sort of their necessarily specific set of circumstances. And in general, advice is good to the extent that it is like takes into account like where you're starting from and what would move you in a most profitable direction. And I think most advice is not like that kind.
Now, I highly encourage everyone to subscribe to Construction Physics. I also follow you at _Brian Potter on X. By the way, why the underscore? Why do you have was it Brian Potter taken or something? Or
yeah, Brian Potter was taken. I could have done Brian Potter 2727 or something like that. But the underscore seems good. I saw a few other people do it. I was like, oh, seems like a good way to get something that's close to like your actual name or
yeah, okay. You gotta like you have to somehow like buy it from the other guy.
Yeah, I know.
Out there.
I couldn't get maybe someday.
Well, this has been awesome. Thank you, Brian Potter, for joining us, World of DAS. And I definitely encourage our listeners to both subscribe and follow you on X. This has been really great.
Yeah, thanks for having me.
Thanks for listening. If you haven't already done so, please subscribe to World of DAS wherever you consume your podcasts, YouTube, Apple, Spotify, and more. And please help us get discovered by leaving a review. And check out worldofdas.com. That's worldofdas.com. And of course, connect with me on Twitter at Auren. That's AUREN. Would absolutely love to hear from you.